we proceed to the third session on emerging disruptive technologies. This session will analyze the emerging trends in warfare and crystal gaze into the future battlefields. It will also dwell on emerging disruptive technologies, cyber warfare, threats and opportunities, and on technology and sea power. This session is chaired by Lieutenant General Rajeev Sabherwal, PVSM, AVSM, VSM, retired. The detailed biodata of each chair and the speakers are given in the brochure. Only the salient aspects will be highlighted during the webinar. The biodata of the esteemed chair is as flashed on the screen. General Sabherwal is a paratrooper with a military career spanning almost 4 decades. The officer had multifarious operational experiences in both conventional and counter-terrorism operations. A graduate of Defence Services Staff College, Wellington, High Command Course, Mau, and National Defence College, Delhi. He has also been trained abroad in electronic warfare at Budapest, Hungary. The General Officer was the first paratrooper to be appointed as Signal Officer in Chief. The General currently holds the Chief of Army Staff Chair of Excellence and is a Distinguished Fellow of Center for Land Warfare Studies. We will be talking today about disruptive technologies and land forces operations in Indian context. Our first speaker in the panel is Professor Chuck Freilich, former Deputy National Security Advisor of Israel. Professor Chuck Freilich, a long-time senior fellow at Harvard's University Belfer Center, teaches political science at Columbia, New York University, and Tel Aviv University. He is the author of Zion's Dilemmas, How Israel Makes National Security Policy by Cornell Press, 2012, and the Cyber Threat, How the Startup Nation Became a Global Cyber Power, which is forthcoming. He will be speaking on cyber warfare, threats and opportunities. He is joining us live from Israel. Our sincere appreciation to the professor for joining us at this event, despite the inconvenient time difference. Our second speaker for the session is Vice Admiral Anil Chopra, PVSM, AVSM retired. The Vice Admiral superannuated in the year 2015. Vice Admiral Chopra has the unique distinction of having been the Commander-in-Chief of both the combatant commands of the Indian Navy, that is the Western and the Eastern Naval Command, as well as being the Chief of the Indian Coast Guard for 3 years in the immediate aftermath of the 2008 Mumbai terror attacks. At sea, the Admiral commanded the Navy's sword arm, the Western Fleet, and the aircraft carrier INS Virat. He has been a member of the National Security Advisory Board and of the Apex Defense Acquisition Council. Vice Admiral Chopra will be speaking on technology and sea power. With that, I will now request the chairperson to commence the session 3, please. General Sabherwal, please.
First of all, a very good morning to all the attendees, whether they are in the physical domain or in the virtual domain. My esteemed co-panelist, let me welcome you all to session 3, which basically speaks of disruptive technologies in the context of the topic given to me is land forces operation. But in the future battles of ours, we'll be only fighting in multi-domain operations. So therefore, I put it into the right context of disruptive technologies as applied to multi-domain operations actually. Now, since yesterday, speaker after speaker has spoken a lot on disruptive technologies, and a typical layman listener would have got an impression that it's the technology which wins us wars, or weapons which are based on technology would help us win wars. So I thought, let me put everything in context, get it down to some subsets of based on the foundation of technology, and try and tell you all what exactly are disruptive technologies, which are the disruptive technologies which Indian armed forces should put the money on, when should they put their money on. The timing is very, very important. Technology per se can be read by most of you on Google or on any particular site. That's very easy to understand. So I'll just highlight certain technologies, but basically I try and give the complete understanding of disruptive technologies to a layman also. Let's dive into it. Now, if you see most of the wars which have taken place, I won't start off from Mahabharata, Ramayana or something. Let's start off just from the place where Industrial Revolution took place. You'll realize that each technology came up because to fulfill the needs of war. So suffice to say, hitherto till information age, technology was basically being driven by the needs and demands of warfare. Whether it was nuclear blast in Hiroshima, it was U-boats, it was tanks, it was anything, telegraph, etc., whatever you want to call it. But a great change took place at the end of Cold War when the information age dawned on us. That is the time somewhere late 80s, early 90s. And that is the time when a marriage of a communication and computation took place. What you have, all of you have smartphones, is a perfect example of where a marriage of communication and computing has taken place. The day this marriage took place, it led everything becoming smart. So most of us today are carrying smartphones, smartwatches, smart TVs, smart refrigerators, smart devices. And in our parlance of the armed forces, we call ourselves smart entities. So any sensor, shooter, and decision maker who can send and receive data today is called smart. The moment the world became smart, there was a huge disruptive change in the way technology took off. And today, most of the technology, disruptive technology, which are coming up are basically on they are ICT driven and based on whatever I'm trying to tell you today. Now, what else took place because of this evolution of technology? I've given 3 examples. I can increase these examples to number more. Let's take the first one, sensor, shooter, and decision maker, where smart entities and the networks which linked these sensor, shooters, and decision makers took place. It led to a new kind of warfare called network-centric warfare. New computing took place, led to cyber warfare. New communications in terms of radios, whether they were conventional radios or software-defined radios, gave you new forms of electronic warfare. So today, technology itself is raising new kinds of warfare. Most of you have heard of swarm drones. A small, humble drone has led into a new kind of a warfare where we have swarm drones changing whatever we want to change. So therefore, suffice to say today that the warfare today is being driven by technology. And we cannot close our eyes to it. Now, why is that when we got commissioned, most of us, we had never heard of this word called disruptive technology. This word came up only in 1995 once Clayton Christensen coined this particular word. And why is it so abuzz today? My first point is the rapid pace of disruption in information age. In the recorded history since Mahabharata maybe, that is before, let's take the Industrial Revolution, the recorded history of the number of disruptive changes which is taking place is much, much lesser than what disruptions have taken place in the last 200 years. And if you see the disruptive changes which have taken place in last 2 decades, it is much more than what is taking place in last 200 years. And as we go by, you will find the rate of pace of disruption would be much faster and faster and faster. And therefore, if we do not exploit, leverage, and adopt technology or disruptive technology today, we'll be left behind. Balance of power. Our immediate neighbors are exploiting disruptive technology and tilting the balance of power. China is a prime example. Disruptive technology gives out of proportion dividends or asymmetric advantages, whether it is a non-state state actor or it is whosoever it is. Swarm drones is a perfect example. Countries like Israel, Japan, very small in size, but sheer leveraging on technology, they can do what they want to do. And my last point is that kinetic today is shifting to non-kinetic, primarily because of ICT or primarily because of technology. And it is reducing boots on the ground, and it will continue to happen. These are some of the major reasons. There are some more reasons in this also. So with this as background, let's try and understand what is disruptive technology. Broadly, disruptive technology falls into 2 verticals, sustaining and disruptive. 99% of all technologies which you read of are sustaining. They are not disruptive. It is just 1% or even lesser than that. Now, sustaining technologies are further divided into evolutionary and revolutionary. What are these? As applied to, let's say, typically of land warfare, evolutionary will be something which is very continuous, what is very incremental. AK-47, AK-56, AK-103, AK-203, these are all evolutionary technologies. Revolutionary, a set from analog becomes digital overnight. This is revolutionary technology. Let's take a humble ANPRC-25 set. Today we have got software-defined radios. It's a revolutionary change. So what are disruptive technologies then? Firstly, all disruptive technologies are also part of sustaining, are also part of revolutionary. They are not disruptive per se. At the core, they are revolutionary. They become disruptive only because of application and nothing else. No technology is born disruptive. It becomes disruptive only because of application. Ultimately, it has to lead to a new way of undertaking operations. If it does not do that, it is not disruptive, whatever be the technology. It has to create a new way of operation for the armed forces, whether it is sea, land, or air. Let me try and clear some more jargon to you. Difference between what is military innovation, military disruption, and RMA. Typically, we use this word military innovation. It is nothing but any current technology which has been innovatively applied. Just an example I've given you, tanks were already there in 1948. They were there in World War II, but they were very innovatively applied in Zojila Pass. No one expected tanks to be there. We would call this as innovation. We have our innovation mela every year in December. Chief gives the awards also. There is a competition which goes on in this regard. What is military disruption then? Disruption would be new technology which has been innovatively applied. For example, UAVs were already new technology. But the way NATO, US, and other major countries applied it very innovatively and turned it into a UCAV or a drone would be called military disruption. Then what is RMA? Let's take an example of cyber, electronic warfare, and space. These three major warfare things have been combined together by China, US, and so many other countries. This has led to a doctrinal change in terms of integrated network electronic warfare and CIMA, etc., which has further led to an organization transformation in terms of SSF by China and the 11th Unified Command US Cybercom by US. This would be called as an RMA. So with that, how do Indian Armed Forces recognize which out of the plethora of disruptive technology which are there in the horizon and which we keep banding about, where do we put our money? Where do you get a bang for the buck? Now, any technology has a typical 4 stages to it. The first stage is what is called the R&D stage, which I would like to call as a bleeding edge, where you can put money, but there are no returns. Quantum computing today would be an example of this. But at a certain point of time, the technology, there is enough traction for that technology to move from the negative axis to the positive axis. And this is the place we call a leading edge. AI, autonomous systems, Internet of Things, 5G, etc., all examples of these things, which have gained suitable traction to move into the positive edge. At a certain point of time of the technology, of its life cycle, it reaches maturity, where it is freely available, the costs have come down, it can be adapted by anyone. Typical examples would be LTE, 4G, cloud computing, data analytics, etc. And at a certain point of time, the technology decays and new technology disrupts that old technology. 3G probably would be a typical example of that. So when does Indian Army or Indian Armed Forces strike at the right curve? It will be somewhere between the decision point where I've mentioned decision point and maturity, depending on how much money you have. Somewhere at the decision point, the technology will be very expensive, it will be very scarce, it will be probably controlled by the major powers. When the technology is at maturity stage, it will be very freely available to most of the countries. So armed forces will have to go in for technologies which are basically around ascent, around maturity, and few parts of our weapon system will have to be towards 3G or toward, it has to be a mix of these. It cannot be just disruptive only. To help us strike the technology curve at the right time, I've given certain points. These are self-explanatory. Some examples of disruption in Indian Army. Humblest of example, compass and GPS. AVAN. Most of us would remember we used to carry those messages and go and give it to signal center, and they used to key it in, and whole night the shift after shift, the signal center shift used to take place. Today, all that is a history. All that is a past. Today, AVAN part 1 and now version 2 of AVAN, which has just been inaugurated about a fortnight back, has totally disrupted the way Indian Army used to do the messaging. Integrated missile development program of ours. It just totally disrupted the conventional and brought the balance of power back into India's shores. The 3 major networks of the services, ASCON, FNET, and NEW. Let's take an example of FNET. FNET combined with IACCS has totally disrupted the way Indian Air Force used to operate. And now there are so many applications of there like EMALS, like MOSAM, and there are so many other applications which have disrupted the way Air Force used to operate and carry out their warfare. Similar this thing is required by Navy and Army too. So let's now just get a hint of certain technologies as to which are the ones which are on the threshold of now erupting and which we should leverage. Let's take the technologies which are in the kinetic domain. Standoff attack missiles like ICBM, cruise, unmanned systems like UAVs, UCAVs, emerging technology, weapon technologies like lethal autonomous weapons, directed energy weapons, railguns, loitering missiles, and so many. Some examples of autonomous ground vehicles. Let's take the example of a loitering missile.
Israel Airways Industries Power anti-radiation drone. The suicide drone. Stay airborne. 6 hours looking at specific radio transmission of radar source on enemy air system. But it's like a specific signal. Signals and deliberately crash into it and destroy its target.
Yesterday, this was alluded to Ghatak. It was shown. This is right now in the laboratory stage itself. This is only on the drawing board. No test has taken place. Maybe in a year or two, we find the first test, I think, of this is scheduled in 2023 by DRDO.
Results in the next resolution in combat in hypersonic technology. Militarized hypersonic weapons exist of 2 distinct purposes. The first is a cruise missile, which relies on an air jet engine that enables it to travel at extreme velocities with ranging between 5 to 10 times the speed of sound. This is in contrast to missiles, which are experimental fuel. The second hypersonic weapons entails a glide, which at launch is propelled by a rocket, but when it enters hypersonic speed, it uses aerodynamic forces to glide with extreme dexterity, meaning change direction in flight does not follow it. That unique maneuverability conceals the glider's flight path seconds before it.
Most of you must have heard of hypersonic weapons. In the last 2-3 months, there has been a huge talk of China firing a hypersonic weapon which circled the entire Earth and came back and nearly hit the target. It was just off by about 20 odd miles from the actual target. Though China has denied it, but suffice to say, hypersonic weapons are the weapons of the future. And India too has made some headway into this. We have a program of Shaurya, which is the hypersonic surface-to-surface tactical missile. We have a hypersonic technology demonstrator vehicle called HSTDV, whose test flight was carried out in first week of Jan this year. Then we also have BrahMos 2, which is a hypersonic cruise missile. And all of these are hypersonic and in a pretty, I won't say advanced stage, but pretty good stage of development has taken place as far as DRDO is concerned on these. Okay, our DRDO too is pursuing 2 programs of directed energy weapons. One is called Project Vajra, one is called Project Divyastra. So Divyastra is the laser weapon system where we intend reaching till about 5 kilometers. We have achieved probably about 2 kilometers right now. And Project Vajra is the high power microwave kind of a project where we want to disable all electronic systems for a range of about 500 meters. We have achieved certain ranges, but the desired capability as of now has not been achieved. The work by DRDO in this regard is still on. Okay, this railgun demonstration which you see was fired by US Navy 2 years earlier. In this, basically electromagnetic force or Lorentz force is used to hurl a projectile at speeds of Mach 7, Mach 8, etc., etc. There is no explosive charge, there is no detonator, etc. Just the sheer projectile is sent at such a huge speed. It can reach distance. This reached a distance of about 370 kilometers at speeds of Mach 8, which is 8 times the speed of sound. Typical application of railgun is in the Navy, not in the Army and Air Force, because it requires huge space, requires huge electricity, And even in Navy, only heavier ships like aircraft carriers, destroyers can use this, not normal ships. Surprisingly, DRDO made the first a kind of a prototype kind of a railgun in 1994 and then shelved the plan. Second time they made this, again a typical small prototype was in 2003. Again it was shelved. Now they have recommenced this particular project in 2017. So in the days to come, maybe we'll find some progress in this. This is just the theory of railgun. Anyone interested, we can cover it in Q&A session. As far as cyber warfare is concerned, I will not touch, even though this is disruptive, and speaker after speaker have said that this is disruptive in a true sense, because there is a speaker, Professor Chuck, who will be speaking exclusively on this, so I will not touch upon this. Now, disruptive technologies are also applied to non-kinetic. If you ask me frankly, they are applied more to non-kinetic than to kinetic. They lend themselves to more. So if you see non-contact warfare, gray zone warfare, hybrid warfare, or any kind of warfare, you will find technology can be applied to any such kind of warfare. And typical applications in non-contact warfare are this. Technologies are big data, quantum computing, IoT, AI, blockchain, 5G, and so on and so forth. Let's take AI. AI today is imperative for all kinds of warfare. It's not only for non-contact. Whether you apply it in autonomous systems, whether you carry out ISR processing or decision support systems or wargaming, simulation, training, medical, logistic, transportation, in any field, AI will be applied. Big data. Most of you have heard of big data. The sensor data could be of any kind. It could be sensors, open source int, human int, social int, LInt, SIGINT, GeoInt, SITREP, satellite. It just collects all this particular data, puts it in the data center, and based, if it satisfies the 5 V's, what are required by big data, analytics takes place, and it helps us, the armed forces, in terms of situational awareness, battle assessment, and decision support systems. Quantum, still in the bleeding edge stage or in the R&D stage, but huge applications are anticipated in this, specifically in terms of quantum key distribution, quantum cryptanalysis, radar, sensing, computing, PNT, and in every field of armed forces. MCT today has opened a quantum lab where quantum key distribution has been proved for a distance of about 70 kilometers. Now they're working to take it to 200 odd kilometers. So some humble headway has been made by MCT, and they also have an AI lab and a robotic lab and a quantum lab. So all these 3 technologies are now being test bedded at MCT. Internet of Things, in the days to come, gentlemen, or rather it's already there. As I said, most of the entities today have become smart. So therefore, entities can talk to each other. So it is not only man-to-man or man-to-machine, but even machine-to-machine communication today is possible to Internet of Things. And everything, including a human being or a soldier, would become a sensor. And soldier would be smart to give that particular communications. Let's move to 5G. Few more technologies, 3D, nano, next generation. And as far as CICT are concerned, low-level radars and hyperspectral imaging are some of the examples which lend themselves to CICT or land warfare. With this, I have come to an end, gentlemen. And for the next part of the talk, I'll hand you over to Professor Freilich, who will be speaking on cyber warfare, threats and opportunities.
Okay. Good morning. Thank you for the invitation to be with you today. And it is a pleasure to share this panel with 2 such distinguished people, General Sabherwal and Admiral Chopra. It is a pleasure to be with you. And let me also stress, I had the pleasure of serving on the NSC in Israel, the National Security Council, just at the time when Indo-Israeli relations were taking off in the early 2000s. I'm pleased that they've continued to progress greatly since then. And so when I say that it's a pleasure to be with you this morning, I really mean it. Now, some people maintain that cyber will have a greater impact on state power, military might, warfare, even than the Industrial Revolution. Truly disruptive effects, as General Sabherwal was talking about. And if this is true, then it will require a fundamental rethinking on our part about national security strategies. And so the question that I will pose this morning is whether the effects of cyber have been merely significant, we all agree on that, or whether it has truly been transformative. And to break that down, I will try and ask a number of important questions. There are more, but I think these are some of the critical ones. And the first one is, does cyber pose a challenge to the very concept of statehood? It's a complicated issue. I will just give you a few examples. First of all, states do not enjoy a monopoly of force in the cyber realm. And a monopoly of force was traditionally considered to be one of the fundamental attributes of statehood. States also have less control over their cyber borders than their physical ones. The ability of cyber attacks to cross state borders casts doubt on the traditional role of national militaries as the guardians of the state. They're no longer the sole or the primary guardians. Most cyber attacks actually take place against private individuals and against public and private entities, various firms and organizations. Given the vast number of attacks, only these private entities can ultimately provide for their defense, not the state. The state can help, but it can't be the guarantor. Significant kinetic capabilities require state-based capabilities, state-based resources. Anyone with a PC can cause at least some damage, maybe not too much. You usually need more than just having a PC. But small states, small non-state actors can wield totally outsized capabilities in the cyber realm. The giant tech firms, their digital power, the global digital infrastructure that they control rivals and in many ways exceeds the power of states. Second question, can cyber attacks truly cause systemic disruption and destruction, political, economic, and military? If so, severely undermining the ability of an enemy to function. Now, systemic effects of that's a big word. All other weapons to date, including nuclear ones, are relatively localized. Only cyber can achieve that kind of systemic effect. And if it can really be done, an enemy could be defeated without resort to kinetic warfare, without loss of life. No other military technology, conventional or unconventional, has ever had this capability. Well, to date, full systemic effects have yet to be demonstrated. The Russians partially demonstrated it, especially in Ukraine. Some are skeptical that full systemic effects really can be sustained over time. Well, time will tell. Are cyber attacks more escalatory or less so? Well, states conduct cyber operations in order to pursue and promote their national security. But in so doing, in pursuing their national security, they inherently impact the national security of other countries, force them to take countermeasures, and you lead to the classic security dilemma. Some of the primary advantages of the cyber realm, for example, the ability to cause disruption and even destruction without loss of life, can increase the temptation to use cyber and possibly further increase the risk of an escalatory cycle. There are others who believe that cyber, and this is probably the majority view today, that cyber is less escalatory. They note that cyber attacks, unlike kinetic ones, can remain under the radar in the gray zone almost indefinitely. that in these circumstances, publics may not be aware that attacks are even taking place. And if that's the case, then political leaders, especially in democracies, stand to gain greater decision-making leeway. They can decide how and if they wish to respond to cyber attacks, greater leeway than in kinetic attacks. Those who doubt the escalatory nature of cyber also note that just in practice, from what we've seen so far, states seem to respond to cyber attacks with cyber attacks and proportionally in a way that is designed to minimize the dangers of escalation. In practice, we have only seen, there are only 3 known cases to date of states responding to cyber attacks by kinetic means. And conversely, the opposite happens all the time, numerous cyber responses to kinetic attacks. So is cyber more or less escalatory? The jury is out, but leaning in the less escalatory direction. Is cyber offense dominant, defense dominant, or neither? Those who believe that it is offense dominant stress the fact that every new version of hardware or software that comes out presents new opportunities for the attackers and new problems for defenders. The attacker, remember, only has to succeed once. The defender may have to succeed all the time against all attacks. Those who conversely believe that cyber is defense dominant note the fact that advanced cyber weapons, maybe not the simple ones, but advanced cyber weapons require considerable investments in time, expertise, money. The defenses needed to thwart them may be relatively simple and inexpensive. Even minor changes to a targeted system for routine maintenance can thwart the most advanced cyber attack. And apropos General Sabherwal's talk, the various disruptive technologies of big data, AI, quantum computing, well, at least some of the experts believe that this will swing the balance in the direction of defense. In short, once again, the jury is still out. How has cyber affected intelligence operations and information operations? Here, I don't think the jury is out. I think the effect here has been revolutionary. Intelligence agencies used to have to go to great lengths to develop just one source. Modern cyber intelligence is conducted on an absolutely industrial scale and with remarkable effects. Intelligence operations today can reach information operations can reach huge numbers of people directly, instantly, at minimal cost, dwarfing all previous capabilities. Offensive information operations have become an effective means of sowing political and social discord, threatening state societal cohesion, and disrupting political processes. The Arab Spring was an early demonstration of that. The effect of the Russian information campaign against the US elections is a later example in democracies. Defensive operations have become a means of political control and oppression in authoritarian states. Now, I wanted to talk about cyber's impact on the 4 classic dimensions of military strategy: detection, deterrence, defeat, and defense and defeat. Also talk about the newer concept of resilience. For reasons of time, I will very briefly just touch on 2 of them: deterrence and cyber defeat. Can cyber deterrence be achieved? Is it at all possible? Well, at least the US, UK, and some other countries' national cyber strategies are all explicitly based on the assumption that deterrence is at least as applicable to the cyber realm as it is to the physical. Well, there are experts who challenge that, they say, just look at the very prevalence of cyber attacks. That would indicate that maybe deterrence isn't possible, that deterrence simply isn't applicable to the cyber realm. Nuclear deterrence worked well because the sides knew that on the one hand, there was no effective defense, and on the other hand, they had mutually assured destruction. Well, in the cyber realm, defense is possible, and there is no assurance of mutually assured destruction. Standalone cyber deterrence is probably not feasible, but cross-domain deterrence is. In other words, the application of all of the sources of state power, economic, diplomatic, kinetic, and of course cyber, the application of all of them together. And cross-domain deterrence will be particularly effective when applied together with cumulative deterrence. In other words, the repeated frustration of an adversary's attacks, repeated prevention of the adversary's attacks, up to the point that the adversary realizes that continuation is futile and ceases to continue. Can cyber adversaries be defeated? Well, classically, or traditionally, defeat was defined as the ability to use physical force to prevent an adversary from being able to wage a conflict or to undermine its will to continue fighting. Physical force is not used in the cyber realm. And much as standalone cyber deterrence is probably not feasible, standalone cyber operations are unlikely to be sufficient to defeat an enemy. As with deterrence, cyber defeat requires the application of all sources of state power, the ability to blend them into one coherent framework. I would suggest for thought that instead of speaking in terms of cyber defeat, we talk about cyber superiority. And I would say that cyber superiority refers to two things. First, the ability to impose a level of disruption or destruction on the adversary so that it can no longer function effectively. And conversely, the ability to reduce the number and severity of the attacks on our side to a level that we can tolerate and at which we can continue to function without significant disruption. The bottom line, cyber may or may not have had a fundamental change on the nature of warfare. It doesn't change everything, and we shouldn't expect cyber or any other single technology to change everything. But the fact that there are important areas of continuity does not detract from the enormous magnitude of the change that cyber has brought about. The traditional balance of power is being superseded by cyber power, whether military cyber or civil. Cyber plays an increasingly important role in foreign relations and international diplomacy. States that have successfully harnessed the cyber realm have successfully translated this power into a diplomatic and economic power as well as military. Cyber capabilities are, of course, now a critical component of military power. So I think the bottom line is that cyber's impact has certainly been significant and in some important areas, absolutely transformative. Let me conclude with a word about Israel and Indo-Israel relations. Israel was one of the first states to awaken both to the threats and opportunities posed by the cyber realm and to develop the necessary capabilities to address both of them, to respond to the threats and take advantages of the opportunities. And there is really a remarkable story to tell here, how a nation of 9 million people has come to be considered one of the world's top 5 cyber powers, both military and economic. At the same time, Israel is also one of the states under the greatest number of cyber attacks, and cyber is defined today as one of the top few threats that Israel faces. India, of course, is also a center of technological intelligence and also a focus of cyber attacks. Well, I am pleased to say that in recent years, a number of important cyber cooperation agreements have been signed, bilateral agreements providing for cooperation both in the areas of national capacity building and in the operational areas. And I very much hope these ties continue to expand. Thank you.
Of warfare, that is cyber warfare. And he's very lucidly brought out that cyber today is not only confined to a single domain as we try and understand that, but it has cross-domain effects, cross-domain linkages. It may be classically borderless or anonymous, but it has linkages all over. And there is a whole of nation approach which is required both in economic, political, social, armed forces, Army, Navy, Air Force, if you want to do something about it. He brought out the 4 Ds, detection, deterrence, defeat, defense, very nicely. And we tend to agree with him that very few nations today have spelled out a national cyber deterrence policy. I think US is one of them, which is spelled out. India is still to spell out a cyber deterrence policy. A question which comes to our mind is, would cyber attack be construed as an act of war? This is the question which normally is posed at the end of every seminar, and I'm sure in the Q&A session, Professor Chuck would like to speak something on this in this regard. Thank you so much, Professor Chuck. It was a wonderful talk by you. Now we'll invite Admiral Chopra to speak on technology and CPAR. The floor is yours, Admiral Chopra.
Thank you, Chair, and good morning, everyone. Many thanks to Klaus for giving me this opportunity to share my thoughts on the impact of disruptive technology at sea. It is a rather broad canvas to cover in 15 minutes, but I'll give it my best shot. It is often said that the Navy is the most technologically advanced of the 3 services. Many studies highlight that the first nascent modern technologies mushroomed in the 15th and 16th centuries during the age of exploration in response to the demand of sheer survival and navigation at sea. And you had things like the precise chronometer, surgical techniques, and food preservation. These inventions and innovations possibly spurred the industrial and scientific revolutions which followed in later centuries. Now, be that as it may, I would like to begin by underlining that at sea, technology is not only imperative for weapon systems, but for every aspect that a warship faces, from hull design and ship construction itself to propulsion, power generation, communications, aviation, and a host of other diverse capabilities that ships have built into them, operating as they do in high-risk environments, far from all the support we take for granted on land. Now, the ocean is not conducive to human life. It is vast, barren, turbulent, and a hostile environment devoid of any natural shelter or sustenance, in which man has to first learn to survive and float before he could move on and fight. Even before it faces the enemy, every vessel at sea must contend with the constant threat of storm, flooding, fire, grounding, and collision. Think of a warship as a densely packed, hazardous tin can, designed to be as small as possible to reduce various signatures, full of fuel and ammunition and electronics, and jammed with over 500 systems, high-tech systems in every area, from engineering to damage control to missiles to helicopter recovery. The exponential advance of technology that we are talking about, disruptive or otherwise, impacts all these subsystems and failure to incorporate new technology in any of these fields leads to obsolescence, detracts from fighting capability of the platform, and therefore eventually from the ability for sea power itself. Warships need to keep up with technical advancement in a multitude of disciplines, from new materials to noise-suppressing technology. I would also like to underscore that it is not easy for even the latest technologies to overcome the inherent warfighting challenges posed by the oceanic domain. And since we move away from the air-land battle, I'll take a while on this. The ocean is one unbroken, interconnected continuum. No boundaries, no borders, no fences. Access to any one part of it allows you access to all 70% of the planet's surface. The war at sea is all about constant mobility and offensive maneuver in all directions or in any direction you wish. Therefore, searching for, locating, identifying, and targeting the enemy is still pretty complex, even in this day of satellites. The ocean is also vastly humongous and far from transparent. It is still relatively easy for ships to disappear in the natural opacity that the seas offer. Searching for a ship on the high seas is an onerous task, even in today's times. And then there is identification. The ocean belongs to no one. No state or company or individual is neither owned nor controlled by any power or grouping. The seas are free and available for use by all mankind. It is therefore an international arena populated by all types of commercial, military, and leisure vessels from all nations around the world, whose presence continues despite any conflict between any two or more belligerents. In other words, even when located, it is difficult to identify the type and nationality of a vessel and all the attendant problems of collateral damage. That is why Maritime Domain Awareness, or MDA, has become an article of faith in this age where sensors of all types can actually give you hundreds of contacts in any given area. Even if identified, it is difficult to constantly track a target. A ship has a 360-degree freedom of movement unhindered by terrain or roads. Even 1 hour after a reported sighting, the search area to relocate expands to a circle of 2,000 square miles. Keep in mind that ever since the advent of the submarine in the 19th century, maritime warfare became two-dimensional. Aircraft made it three-dimensional for well over a century now, and wireless radio began the process of adding various overlays from the electromagnetic spectrum through radar and EW, as we see in times to come, plus acoustics and sound for underwater warfare. And now all this has yet been overlaid by cyber and space. The impact of exponentially advancing, so much for platforms and domains. Let us look at the contemporary scenario. The revolution in military affairs, as General Sabherwal said, after the Cold War, has indeed transformed maritime warfare. I'm not going to go through a list of the weapon systems and technologies, which has been adequately covered, just to say that the impact of exponentially technology, I think, can best be illustrated by the experience of my own generation, which witnessed a total sea change in our limited decades of service. When I joined the Navy as a cadet in 1975, ships were not yet fully air-conditioned because they were not packed with electronics. Bridges were open, and in rough seas, we actually got wet. The weapons were mostly guns, which required manual settings and operation. Communication was still by semaphore flags and flashing lights, and one could hardly use radio as breaking silence gave away one's position. The average ship did not carry helicopter or drones, and of course there was no internet, no space assets, and no high-speed data links. to share information between various units, ships, submarines, and authorities ashore. When I retired 40 years later as a CNC, the revolution had happened, and satellites and internet were so integrated into warfighting and that sitting in my underground headquarters ashore, I could monitor, direct, and communicate in real time with all assets deployed over 1 million square miles from the Suez Canal to the Malacca Straits. All platforms had satellite navigation and satellite communications, and the Navy was completely into network-centric warfare and the beginnings of cooperative engagement capability, where one could connect the best sensor to the best shooter in any given situation. Through data link, we could replicate the radar screen of a helicopter flying 1,000 miles away in the operations room, which functioned on a common operating tactical picture shared with the fleet commanders at sea and naval headquarters in Delhi. Missiles could now hit ships and land targets at ranges in hundreds of miles. Integral aviation assets were distributed across all ships and not concentrated on aircraft carriers. We could keep track of hundreds of commercial ships and aircraft through MDA and were vastly better informed than our predecessors, even at the turn of this millennium. All this made us far more potent, but far more complicated, and if I may say, far more fragile, because these systems are prone to sometimes catastrophic failure. More importantly, we observed tech was followed by counter-tech. In war games, neither the attacker nor the defender was overwhelmed. So what more is likely in the future at sea? Though gazing at technology is a difficult task, the broad objective of modern technology is essentially to create an omnipresent kill chain in the area of interest through a multitude of sensors and shooters connected to each other and to concerned command authorities through seamless communication and data links, satellite data links. This requires continuous real-time observation using all the various sensors available, including aircraft and drones and space, and as General Sabherwal mentioned, the Internet of Things, a plethora of cameras, pressure, temperature, infrared, and movement sensors placed all around in the battlefield or the battle space, all connected to AI C3I systems, which can evaluate, prioritize, and engage all this information. There is little doubt that the miniature, ubiquitous sensors of the kind now found on your smartphones will lead to a more transparent battle space at sea by installment of these on small air, surface, and underwater unmanned platforms and also on the seabed. This will certainly detract from the natural strength, stealth, and opacity that navies enjoy, but it does not mean that surface ships and submarines will become unviable or obsolete, as suggested in some uninformed discussion. These platforms will counter probing eyes through the destruction of sensors, deafening or jamming them, through deception, through decoys, and through disruption in a counter fashion in an unending game of hide and seek. So I'm not particularly overawed by disruptive technology because it is not one-sided. The omnipresent, all-prevalent sensors like synthetic aperture satellites, which can see through the dark and through clouds, also produce a glut of data which needs massive processing and AI to be made sense of. All cyber AI and decision support systems are vulnerable and can be fooled. Offensive cyber warfare is just one of the means of disrupting the notion of any foolproof transparency that technology brings us. Remotely controlled or AI-controlled unmanned systems will doubtless proliferate, but they are also subject to a host of tactical, hard, and soft countermeasures which preclude any dominance, as I said, in my experience, of attacker or defender. Speed and range of munitions, including hypersonic missiles, and their accuracy and destructiveness will keep getting enhanced, but then so will it be for the air defense systems, which will be shortly boosted, as you've seen, by directed energy weapons. The latest US Navy destroyers have been fitted with these laser weapons, as showed to you by General Sabherwal, and so the game of hide and seek, kill and counter kill will carry on. Weaponization of space has become a reality, with ready-to-use munitions being placed in orbit. However, anti-satellite technology and ballistic missile defense will also see better performance. The most interesting space to watch could be the underwater domain, where it remains to be seen whether technology can penetrate the ocean depths to nullify the stealth of submarines. The upshot of all this, however, will be the OODA, the famous OODA loop, would reduce, and time from being spotted to time to being dead will reduce, definitely. In fact, as you all know, the US is on track for a prompt global strike system, which aims to strike any place in the world with conventional weapons within 1 hour at max. More importantly, in my view, and this is as for all three services, contemporary technology may impact on 3 of the oldest principles of war: mass or concentration of force, maneuver, and surprise. In response, new warfighting concepts, such as the US Navy's distributed maritime operations, are being introduced, where naval forces will fight widely dispersed, coming together briefly in time and space for the final kill. As we have talked, joint all-domain operations which seek to produce mass, surprise, and maneuver through technology. Now, the Navy has been facing a 3-dimensional multi-domain scenario for over a century, and it changes some things, but it doesn't change others. For example, with all the technology, we conduct a standard tactical appreciation in much the same manner as in the Second World War. There is also increasing focus on platforms of ability and modular construction, so as to which you can amend damage which is sustained in action. As far as warships are concerned, there has been a dedicated movement over the last few decades to reduce all signatures, radar, infrared, pressure, etc., and become more difficult to observe and locate by any sensor. Air defense technologies have also exponentially improved with multiple tiers of defense and also the ability to track hundreds of targets simultaneously. Navies continue to focus on deception and decoys, and on aircraft carriers, methodologies to increase number of aircraft and combat air patrols through evolution of hangar stowage, lifts, and launch and recovery electromagnetic systems has added to both the carrier's strike and air defense capability. I would like to conclude by stating that technological advancement has always disrupted the status quo in military matters, whether it be the chariot, the longbow, gunpowder, submarines, or satellites. The military, however, have always countered every technology with counter-technology and tactics. We should not get overawed by new and more expensive tech as to put our eggs all in one basket or fewer baskets. History has taught us that quantity has a quality all of its own, not to be forgotten. Attackers still look for 3-to-1 ratio in combat. At sea, one platform, however advanced, can only be at one place at one time and can easily be rendered unserviceable by the high tech itself. Numbers will always matter, as indeed will professionalism. Over-reliance on the internet and on satellites and space and cyber comes with its own share of risks, as would be obvious to all of us who face big breakdowns on Wi-Fi routers and power supply in our homes. Unmanned platforms also have their pitfalls. While they reduce the requirement of operational manpower, they greatly increase the number of people required for maintenance and support. the teeth to tail ratio actually goes up when switching to high-tech lean crew platforms. As an example, it took NASA a tale of 50,000 people to put the teeth of 2 astronauts on the moon. As we all know, there are many other factors besides technology which decide the outcome of battles, including the intangibles such as leadership, morale, training, and tactics. In addition, geography, weather, and of course, general luck plays a great part. So it was my message, it is my message, of course, that we address the technologies which emerge and disrupt, but we should not really think that the way we fight or the way we attack or defend will change in any great, it will not change the nature of war, it will only lead to evolution of doctrine, concepts, and tactics. Only the speed of change will be demanding, and the winners will be those who are more situationally aware and who adapt the quickest. I was also asked to dwell a bit on the Indo-Pacific. There's no time, but suffice to say, as far as tech is concerned, the Americans and the Japanese are still ahead of the Chinese, whose naval platforms remain untested in combat, while the Japanese and Americans have been through 6 years of Second World War and much thereafter. Though the PLA Navy has made considerable strides in force levels and infrastructure, its operational concepts and experience and maritime remain suspect. I was about to show 5 slides to sort of indicate the Indo-Pacific scenario, but as I see in the interest of time, I will not do so. And thank you very much for your ears, and thank you.
So much, sir. Starting from his own early days at sea, he has covered various technologies which are affecting the character and nature of sea power. And thank you so much, sir, for your wonderful talk. Now, coming to the Q&A session, I request the panelists to keep their answers very brief. Due to paucity of time, I have a plethora of questions with me, but due to paucity of time, I'll just restrict the number of questions also. Okay, the first question is to Professor Chuck. Since attributability is a major issue faced by countries in the cyber domain, where we don't know about origins of attacks, does this create incentives for states to escalate the conflict as deterrence is being eroded?
Of course, there is a question of attribution, a problem, but that I believe that at least advanced cyber states have developed both technological and forensic capabilities that usually enable them to make attribution, at least at an intelligence level. Maybe it wouldn't be enough in a court of law, but for intelligence, for policy-making purposes, attribution is usually feasible today, at least for advanced states. The real problem isn't whether they can attribute the attack, but how long it takes. It's also resource intensive. Sometimes it takes longer than is appropriate for the needs of the policymakers. They need a quick answer. And maybe that can't always be done. But usually you can attribute, especially most of us know who our enemies are. It's harder for the global superpowers because they focus on the whole world. Those of us who have a more limited range of threats, or at least sources of threats, it makes it a little bit easier. We're familiar with, more familiar with their modes of operation. Their motivations help indicate where the threat may be. I don't think attribution is as great a problem as it used to be made out as.
Question, which is again posed to you. What is the way forward when it comes to establishing a sustainable international norm for managing whole array of cyber crimes and its manifestations?
Okay, well, I wish I knew the answer to that. There is a great deal of controversy. There have been attempts for the last couple of decades to develop international cyber norms, let alone law. And actually the only area in which there are any international binding or semi-binding international agreements are in the area of cyber crime. So far we've had less success developing norms regarding the other aspects of cyber, the military ones. And it is a critical issue. There are international law experts who debate this at great length. I am certainly not an expert on international law, but I think most people in the West, certainly India, certainly Israel, I don't know what India's position on this is, but that international, the laws of armed conflict, international humanitarian law, apply to the cyber realm. And then you have questions of how exactly you define a cyber attack. The international law experts differentiate between international wrongful acts, uses of force, armed conflicts, armed attacks. There are critical questions here of, is just a loss of functionality sufficient to trigger the right to self-defense, to trigger the laws of armed conflict? Do you actually need physical damage and or loss of life? This is an entire world of discussion, and I suggest that we leave it for people who are greater experts than myself.
Thank you. Okay, the last question for today is, what are the key disruptive technologies that will impact land forces operations in the coming future? And how does the integration of technological component impact the effectiveness of land forces operations? For this, I would recommend the technologies which have the ability for weaponization and lend themselves for employment in operations below the threshold of direct conflict are the ones which are recommended ones, specifically for land operations, I'm saying. Examples could be unmanned systems, information systems, electronic warfare, cyber warfare systems, anything concerning net-centric staticity. These are the recommended spaces where disruption or attempts to disruption should be achieved. A disruptive technology which lends itself towards deniability would be the ones which are preferred. As far as the second part of the question of integration of technological components, technology, as I said earlier, technology per se cannot win wars. Technology is normally embedded into a weapon systems. Weapon systems themselves cannot win you wars. The weapon systems have to be applied to a particular operational doctrine or concept, which then has to be executed well, which is based on the foundations of disruptive technology or emerging technologies that can lend towards our operational advantages or towards our victory. So that is the place where the technology integration would lend themselves for any kind of warfare, whether land or air or sea. With that, all that's left for me is to thank both my co-panelists for the wonderful insight into their respective subjects and our heartfelt gratitude to both of you. And thank you so much to the audience also. And I'll hand you back to sir.
Ladies and gentlemen, with this we come to the end of session 3. May we have a round of applause for the chair and the panelists, please.